this video, I look at weight coding. This form of coding is useful for coding pictures, that is audio information or video information or things like that. Just like I looked in the previous video, we tried to maintain by the invariant by for a larger base, right? So the basic idea, the general approach to this is weight coding. There are two steps involved. Basically, first is weight redistribution. That is, first you try to redistribute the weight fairly optimally. If you do not initially redistribute the weight fairly optimally, then the method, the simple transformation applied here will not be very effective. To that end, I will look at one method. It is not the best way of redistributing. There are other weight redistributions, either both practical or after having done the redistribution, we try to apply this simple transformation in order to maintain the invariant. First objective is to redistribute the weight in such a fashion that the least weight is not too small or too large either. And again, the largest weight also must not be relatively too small or too large. The difference between successive weights will grow by more than W by 2. That is Wi plus 1 greater than 2 times Wi. Okay, this will generally be true. However, the ratios will decrease. That is Wi plus 1 by Wi ratio should decrease. So it does not optimally and reasonable. Least weight must not be too large. Okay. So some of the weights will add up to slightly less than, some ratios slightly less than the next weight. So this property, if you can somehow get it, then you just apply the simple transformation to try and maintain the invariant for a bit case. Okay. So the objective is to code a number which lies between 2 power L dash as a number which lies between, to map a number which lies between 2 power L, where L dash is much larger than L. So among the L bits, we try to distribute the weights of the L dash bits in such a fashion, like I've said before. Okay, let these weights be W0, W1 and so on up to WL minus 1. Okay, the L dash bits. So we might assume L dash equal to n times L. Now we simply now you have here WL minus 1 and WL minus 2. Okay. So now we determine X such that we move from left to right, having redistributed with these weights in such an optimal fashion, fairly optimal fashion. We determine X okay, such that WL minus 1 minus X is equal to 2 times WL minus 2 plus X. Therefore, you get WL minus 1 minus two times WL minus 2 is equal to 3 times of X, right? Therefore, WL minus 2, That gives you WL minus 1 minus 2 times WL minus 2 by 3 equal to X. So now the value of WL minus 2 becomes WL minus 2 into 1 plus WL minus 2 plus WL minus 2 L minus 1 minus 2 times WL minus 2 by 3. Okay, like this. Now for the new value of WL minus 2 and WL minus 3, we apply that same transformation. As a simple case, suppose I assume the weights okay, you have to map 2 power L dash to 2 power L. Sorry, 2 power L. Okay, so I determine B such that B power L plus 1 by B minus 1 equal to 2 power L dash. You will have to determine it numerically. You can try and solve this. B is a large value, so ideally you can determine it numerically. Okay, you can start off with a value slightly less than that, 2 power L dash. Slightly less than 2 power L dash by L, and come less than that, say half of that, say 2 power L dash, and slightly increase it and come closer and closer to 2 power L dash by, it will be less than 2 power L dash by L. Then the weights assigned, we assign to the L bits B power L comma B power L minus 1 and so on up to, B power and so on up to B. Okay, let the value of B power L, let W equal to B power L. Okay, okay, now we need to determine X such that W minus X is equal to 2 times W by B plus X. Therefore, we will get W minus 2 times W by B is equal to 3 times of X. Okay, so that gives us X is equal to W times B minus 2 by 3 times B. Okay, when B minus 2 by 3 times B is added to this W plus W by B, the new weight for WL minus 2, W naught to WL minus 2 will be W by B plus W by 3B times B minus 2, which comes up to W times B plus 1 by 3B. So this is a new weight WL minus 2, and so on. Okay. Now for again we have to determine X such that W times B plus 1 by 3B minus X is equal to 2 times W by B square plus X. Okay, that should give you W times B plus 1 by 3B minus 2 times W by B square is equal to 3 times of X. That should give you X is equal to W times B into B plus 1 minus 6 by 9 times B square. Okay. So this is the value of WL minus 3, which is initial value of WL. This is the quantity that must be added to WL minus 3, which is W by B square. So that value becomes WL minus 3 becomes W by B square W times B into B plus 1 minus 6 by 9 times B square. Okay. So WL minus 3 will be W B into B plus 1 plus 3 by 9 B square. Now we have to do determine X as that WL minus 3 minus X is equal to 2 times W by B power 4 plus X, and so on. You keep. What you notice out here is this value comes out to be close to 1 itself, and this value comes out to be 3 power L. Okay. Okay. Now we have assumed B power L here equal to 2 power L dash. So, right, to represent B requires binary log to the base B bits. Okay. The length of the code itself will be L times binary log to the base B. Okay. Now each time we perform this coding, the last weight will be the least weight, that is the W naught. That is the least weight will be, since we assumed B square, B cube up to B power L minus B power L, the least weight will be, after adding say the value of X, okay, which would be somewhat close to W by 3 whole power L, right? So W by 3 power L. Okay, this is nothing but b plus b by 3 whole power L. This value of b being fairly small, we are largely interested in this b by 3 whole power L. Ideally, we would like to, since the length of the code is L times log B, okay, if we require the number of iterations to be performed for this to be very, very small, say we would like it to be square root of log B or something like that. In other words, we would like it to be actually number of iterations to be performed is log V power 1 by 2, suppose, or 1 by 3, 1 by C, where C greater than or equal to 2. Okay, that means the least weight must be such that b by 3 whole power L must be equal to b power L minus log B power C minus 1 by C times, okay, binary log B of C minus 1 by, okay. Now we transfer it, perform the simple in other words, we require b by 3 whole power L is equal to b power L minus log to the base b whole to the power of C minus 1 by C, which gives us b power binary log of to the base b of whole power C minus 1 by C is equal to three power and take the binary log on both sides, we will get binary log of base b whole power C minus 1 by C plus 1 is equal to L times binary log of 3. Okay. In the words we get, repeating it again, binary log of base b whole power C minus 1 by C plus 1 is equal to L times binary log of 3. Therefore, log to the base b will be equal to L times log 3 whole to the power of c by 2c minus 1, which gives you the base b to be assumed to be equal to 2 power L times log 3 whole power c by 2c minus 1. This is one possible value for the base b. Base b will be slightly large. Right? L need not be too large, but L log 3 will be slightly large. Square root of L log 3 will also be slightly large. But in other words, we can assume a slightly large base, which means we can also afford to recurse it. Same thing with the previous method also, which I said, where you distribute the weights are L power x minus L power x minus 1. You can try and improve on this as well. There is a possible improvement, significant improvement possible with this. Here also, if you assume root, right, instead of coding, we know if m by s is the ratio, square root of m by s by square root of s will be much lesser than m by s. In other words, this redistribution you can try to cut it out over lengths, divide it into parts, right? Then the difference, of course, you will have to add to it, so as you get the length of that will be slightly more. But you can try to do it in that way, in parts. The gain you can get, that is one way, and another way is to try and increase the, right, rather than assume. So this is one way. It is a general form way of coding by which you can use to code. As you can see, the least weight will only be not much, right? So this is one possibility. If you can get the weights, this way of coding, if you can get the weights in such a fashion where the growth is optimal, you can apply this simple transformation to try to maintain the invariance.